Now we are going to take a look at a sheet metal feature called lofted bend. That feature can be found here in the sheet metal ribbon. The lofted bend feature allows you to create a sheet metal part between two sketches using a loft feature. But in what type of applications do we use this out in industry? Well, let's say, for example, you needed to create a sheet metal transition piece between a rectangular piece of ductwork and a round piece of ductwork. The sheet metal part you see on the screen would fill that need. If we take a look at the part, the top of the sheet metal part is rectangular in shape, and the bottom is round in shape. And if we unfold the part, there is the flattened pattern. And notice the outside perimeter of this transition piece. And notice all of the bend lines represented by the center lines. Now if I zoom up on this, you will see from this point to this point is not an arc. It's a straight line, which we say that is a chord. This is also a chord here, another straight line segment. So in reality, when you take this part and put it in a press brake, which is a machine that will fold this into the finished part, you will not have a true circle at the bottom of this transition piece. It's going to be several short chord lines or straight lines that when bent this many times will form something closely resembling a circle. I am going to open up a part file called Lofted Bend Sketch. So if you would like to follow along with me, go into your Working Files folder and open this file. Now you may be thinking that you have used a command before in SolidWorks similar to this, and you probably have. That command can be found on the Features ribbon, and the command you are probably thinking of is the lofted boss base and the lofted cut. Now these two commands are very similar to the sheet metal lofted bends. However, there are some differences. These two features will create a loft between two or more sketches. However, the sheet metal lofted bend is limited to two sketches only. And that is what you are seeing on the screen. And notice, each sketch is required to be a single open profile. And if you look at the rectangle, you can see the opening here, and the same with the circle. In addition, no sharp corners are allowed with the lofted bend feature. So that's why I went through and placed a fillet on all four corners of the rectangle. So we have three requirements for the lofted bend feature. Two sketches only, they must be single open profile, and no sharp corners. Now once we've met those three conditions, we are ready to go into the lofted bend feature. Other than selecting the feature on the sheet metal ribbon, you can also get to this feature by going to the Insert pull-down menu, Sheet Metal, Lofted Bends. I am going to select the feature from the sheet metal ribbon, and the Property Manager opens. Now in this first window here, I am prompted to select the two sketches. So I'm going to go out to the screen, and I will select the circle first, followed by the rectangle next. And you can see the preview of the lofted bend on the screen. Next in the Property Manager, notice we have faceting options, chord tolerance, number of bends, segment length, and segment angle. And notice currently chord tolerance is selected, so you would input this value in this box here. Or if number of bends is selected, you would insert the number of bends in the same box. And the same is true with segment length and segment angle. Now all of these settings here for faceting options will affect all four corners of the sheet metal part you see on the screen. However, if you want to change any of these settings for one corner only, you can go out to the model and select one of these magenta circles. So first, I am going to zoom up on this a little bit and select this circle here. Notice a small faceting options dialog box appears. I'm going to go ahead and move it off to the side so it's a little bit easier to see. The first setting here is chord tolerance. Chord tolerance allows you to set the maximum distance between the arc and the linear segment, and it's currently set at 1 millimeter. Now it's hard to see what we're exactly talking about, so I'm going to bump this number up. And when I get to 10, you can see there is a difference between the linear segment and the arc from our sketch circle. This distance of 10 millimeters is the maximum distance between the arc and the linear segment. And the graphic shows it pretty well. And like I said earlier, because I selected this dot here, this setting is only changing this one corner. So notice I have a 10 millimeter maximum distance affecting this one corner, not the other three corners. I have an option inside of this dialog box to reset to default options, and I'm back to 1 millimeter. The next setting is number of bends. It's currently at 2, and once again, as I bump it up, you will see the bends change on the screen. I'll again reset it to default options, and now let's look at the next setting, which is segment length. This allows you to specify the maximum length of the linear segment. So if I increase this number here, and I'm currently at 25, that is a distance from this point to this point, a straight line distance, a linear distance. Again, I'll reset to default options, and now we'll look at the last setting, segment angle. This allows you to specify the maximum angle between two adjacent linear segments. For example, this linear segment here and this one here. It's currently at 30 degrees, and as I decrease the number, you will see the angle decrease. And again, I'll go back to the default options. So now all four corners of this lofted bend are identical, and I will close out of the dialog box. Notice further down in the property manager, we have some options: sheet metal thickness, bend radius, bend allowance, and auto relief. I am going to scroll back up and close out of the lofted bends feature. On the screen, we have a lofted bend. And now let's go and flatten the sheet metal part. And you can see this transition piece in the flattened state.